So let's talk about the Thrust library now. This library represents an attempt to do away with some of the complexity inherent in CUDA programming. So instead, Thrust provides a very STL-like interface that you can use to accelerate your applications. And Thrust is actually included with the CUDA toolkit and does require the CUDA compiler to operate. So what does Thrust actually do? Well, it saves you from having to manage memory manually. Instead, it gives you these two types, host vector and device vector, and it lets you create resizable arrays that are actually easy to work with. And what you can do is you can assign the values in these vectors, you can resize them, and so on, and even assign elements individually, though obviously assigning elements on a device vector necessarily calls CUDA-memcpy behind the scenes, so it might not be as efficient. And copying values between device and host and vice versa is very simple. You just use the equals operator. And naturally, these device vectors, they can interop with both the STL containers as well as be used in various CUDA runtime API calls. Now, the ability of not having to deal with raw memory is great by itself, but it doesn't stop here. We'll also get support for all sorts of algorithms such as searching, sorting, transformation, reduction operations, and so on, which is great because to this point we've been doing it by hand, and you've seen how complex it can get. One thing that Thrust relies on is the use of functors, essentially structures with the defined function call operator. So you would see a lot of these Thrust : multiplies of float. That's a functor, and you might have to create functors of your own. So let's see just a little bit of Thrust in action. At this point in the course, some of you might legitimately start hating me because I've shown you so much low-level stuff that I'm now going to kind of dispel the illusion and show you some of the high-level stuff with using Thrust. So let's call the project exactly that. So if you remember the trouble we had to go through to do something simple like a reduction operation, for example, then, well, to be honest, you can sort of get away with not doing much of that by using Thrust instead of what's happening here. You're still using CUDA, but we're going to have a different set of include headers. So I'm going to hash include Thrust / and then unfortunately there is no catch-all header, so you have to pick them individually. So I want device vector, I want Thrust host vector. Those are the two I mentioned, and let's have a sorting operation. Thrust sort.h. There we go. Using namespace Thrust. And let's also have ctime using namespace std, like so. All right, so let's have some random function of mine that's going to return a random value from 0 to 9 inclusive. 10. There we go. And what I'm going to do in my main method is I'm going to create an array. Let's have 1024 elements of random values, and I'm going to sort it. And in the process, and I think I made a slight mistake here. In the process of doing this, I'm not going to use any of the CUDA low-level stuff at all, which is a bit disappointing considering we've spent so much time doing it. So int count equals 1024. Now I can make a host vector of int. So that's something that's on the host with the size of count. I can then generate a couple of values, a couple of my random values for the host vector. So here I would use the typical begin age and end age, and just say I want to use my rand as the function to generate these values. So now h has 1024 random values from 0 to 9. And then I can say, well, let's have a device vector. Device vector d. Oh, it has to be specified. Device vector of ints d equals h. Guess what happened there? That's right, we just did effectively a CUDA-memcpy, but we didn't have to write all those horrible parameters. Notice there isn't a pointer inside even. Okay, so we made the copy. We can now sort on the device. Begin d and d. We just sorted some data on the device. We can copy it back, h equals d, and then we can output it. So for I going from 0 to count, let's have cout h at I tab character. Get char, return 0. Let's run this. So here's the result of our invocation. You can see that we are starting with values of 0 and going down to the values of 9. So it obviously worked. And this is how simple Thrust is. And in fact, I would recommend that if you can, do use Thrust as opposed to the low-level stuff, because there is so much that you need to do to get raw CUDA to work for you correctly. Although, of course, if you're into optimization, then yes, the low-level stuff shown in this course is useful. And in fact, it's just great to know how things work. But Thrust is there to take care of most of the heavy lifting for you.